We're Group 8 presenting our interim report for ISD 528 on the redesign of a manual grain mill. This hand-operated grain mill grinds grains with like wheat and corn into flour. It has a hopper, adjustable burrs, and a crank serving home cooks and bakers in a 85 to $215 million niche market driven by artisan and sustainable trends. Let's start with the functional analysis which outlines the key tasks the grain mill performs. Guiding them to the grinding mechanism, crushing them into the floor, adjusting the floor size. Other functions enhance user experience like ensuring convenience, enabling cleaning, and preventing injuries while also improving aesthetics and dependability. This diagram helps us understand the mill's core purpose and user needs. For our redesign, we prioritize functions like crush grains and adjust floor size to improve efficiency and user control. We also focus on enable stability and prevent injuries to enhance safety, which informed our component changes as we'll discuss later. For assembly sequence 1, we start with the crank and end with the hopper. And for sequence 2, we start with the auger and end with the hopper, while the crank comes in between to make it more easier for assembly for sequence 2. Sequence 2, 7 out of 10 beats sequence 1, 9 out of 10 due to easier part location and parallel assembly. We simplified the auger's geometry to ease alignment and assembly and redesigned the crank for ergonomics, improving user comfort and fastening efficiency. This matrix map functions to components showing how the hopper guides grains, grinder wheels crush them, and the crank adjusts pressure. For example, for hopper is only used for containing grain, and to produce flour only hopper and auger are used. These are just some of the examples, and for different functions, different parts are used, and it's mentioned here.
This is exploded bomb view, and as you can see, the mill base is the main component on which there are 7 other major components which will be assembled: auger, crank, and then grinder wheels, and so on. This is our bill of material. There are total 15 components, 9 major components, and then there are 6 fasteners. We have calculated the material cost and assembly cost per part, and the total cost of this assembly is 38.8 US dollar. This is how our chord chart looks like. So as you can see, there are major components in high importance and as well as high manufacturing cost: mill, base, crank, auger, and both grinder wheels. And then there are a couple of components which are low functional importance, but they are high in cost: hopper and handle grip. And there are a couple of components which are having low manufacturing cost but a high importance, which is the mill head and handlebar. Product family design for a manual grind mill. We have considered enhanced aesthetics as a functional difference for a different group of customers based upon their choices. And then the variant will be based upon the colors in these couple of components, which will be modules, and the rest of the assembly will be platform. As a product variants and interfaces, we have selected these two components, the hopper and the handle grip, to meet the customer need of please the senses or aesthetic choice. So we want to provide three colors in these two components: red, yellow, and blue. And then that's how the platform will be the entire assembly except these two parts, and the hopper and handle grip will be modules.